Find the support reactions for the beam shown in figure. This is hinged support. This is roller support. This is horizontal force. This is vertical force. This is inclined force at 120 degrees to the horizontal and 60 degrees to this side horizontally. Now, the simplifying this 10 kilonewton force horizontally and vertical resolutions. This is 60 degrees. Horizontal component will be 10 cos 60 degrees. Vertical component will be 10 sin 60 degrees. This is hinged support. This is roller support. Hinged support will have horizontal reaction HA and vertical reaction VA. Roller support will have one reaction VB. Now, resolving forces horizontally and equating to 0. This is horizontal force HA directed towards positive x-axis. This is 10 cos 60 degrees directed towards positive x-axis. This is 20 kilonewton directed towards negative x-axis. So, HA is positive, 10 cos 60 is positive, HA is positive, 10 cos 60 is positive, and minus 20. This is minus 20. Calculating this equated to 0. Calculating this, we get HA value. Now, resolving forces vertically and equating to 0, that is summation F5 equal to 0. VA directed to positive x-axis plus VB directed to positive y-axis. VA directed to positive y-axis plus VB directed to positive y-axis plus 20 directed to negative y-axis minus 20, 10 sin 60 directed to negative y-axis minus 10 sin 60 minus 20 minus 10 sin 60 equal to 0. VA plus VB equal to 28.66 kilonewtons. So, now taking moment of all forces about point A, HA passes through point A, so moment of HA about point A will be 0. VA passes through point A, so moment of VA about point A will be 0. And this 20 kilonewton force passes through line of action of force like this, and it will have perpendicular distance about point A of 5 meters, and it will rotate about point A anti-clockwise like this. So 20 into 5, 100 anti-clockwise minus. Now 20 kilonewton force, this will have line of action of force like this. It passes through line of action of force like this. It will have perpendicular distance about point A of 4 meters, and it rotates about point A. 20 into 4, 80. 20 into 4, 80. So it is rotating clockwise, so it will be having moment of 80 kilonewton meters positive. This 10 cos 60, it passes through line of action of force through point A, so it will have 0 moment about point A. This 10 sin 60, it passes through line of action of force like this. It will have perpendicular distance about point A of 6 meters to 6 meters, and it rotates about point A like this clockwise. So it will have magnitude of moment of 10 sin 60 into 6 meters. It is rotating clockwise, so 10 sin 60 into 6 positive. Now, this VB force will pass through line of action of force like this. It will have perpendicular distance about point A of 2, 2, 2, 3, 6 plus 3, 9 meters about point A. It rotates about point A anti-clockwise like this. and it will have moment about point A of VB into 9, VB into 9. So we have resolved forces horizontally and equated to 0. We have resolved forces vertically and equated to 0. We got equation in VA and VB. We have taken moment of all forces about point A and equated to 0, and we got VB from this moment equation and substituted VB value back in this equation. We got VA value, we get VA value, we got VA and HA value, and to get RA value we use this equation, square root of summation HA square plus summation VA square. Substituting HA value and VA value, we get RA value. Theta we get by tan inverse of VA by HA. Substituting VA value and HA value, we get theta.